So folks, now we're giving our first introduction to quadric surfaces. We're going to study these in more detail in class, but I want to give you an overall familiarity with them. We'll begin talking about the idea of trace, but then we'll do that more precisely when we get to class. So just to kind of put things in context, a linear surface in R3 is an equation that can be written in this form. And the thing to notice here, first of all, is that not all of these terms can be zero, otherwise we've just got just a number. But then the other thing is that each of these terms has a degree of 1 or less. These three terms all have degree 1, this term has degree less, so this is what we mean by a linear surface. Now, we don't study linear surfaces as their own category because there's only one type of linear surface, and that's a plane, and we've already looked at planes a little bit in this class, and so there's no delineation that needs to happen. But if we extend this idea one further, where all of the terms have degree 2 or less, like I've got here, then what we have is something whose graph is going to be called a quadric surface. So the hallmark of a quadric surface is that it has all terms have degree 2 or fewer, and at least one of the terms that has degree 2 needs to have a non-zero coefficient in it for this to be a quadric surface. Now, this lives in 3 space. And we will usually study the standard, and by that I mean unrotated surfaces, where we assume D, E, and F are all 0. So we're going to go ahead and assume that these 3 terms in this class, these are going to usually be 0, and that makes the analysis that we're about to do a little bit easier. So one of the efficient ways to study quadric surfaces is to fix one of the 3 variables. So notice we've got x, y's, and z's here. And so what we do is we assign a number to one of those 3 variables. Usually we'll assign that number to be 0. And then we will examine the resulting 2D graph when we restrict it to a plane to examine what's called the surface's trace in that particular plane. So each one of these traces, this is why we had to review conic sections, is whenever I force one of these variables to be a number, usually 0, that creates a conic section that we need to analyze. So to understand these quadric surfaces, we need to be able to analyze those conic sections that we talked about in the last video. More often than not, the traces that we'll examine will be the xy plane, the xz plane, and the yz plane, although sometimes we will look at other planes as well. So let's scroll down. So here we've got a quadric surface, and this is our first time exploring it. We've got the quadric surface. It looks like x squared over 4 plus y squared over 9 minus z squared equals 1. And you can actually see, here's the final product, the sketched graph of this quadric surface, something called a hyperboloid of sheet 1. But it's not going to be in our interest to say, hey, if you see this equation, memorize that this equation has this graph. That's going to be a little bit hard to do, although you should be able to start maybe making some quick judgments. Notice we've got x squared, y squared, z squared, so we've got all of these are raised to the second power. This has a positive term, this has a positive term, this has a negative term. So that's all going to be interesting in analyzing it. And after you've done a few of these traces, you might be able to say, aha, I know it's going to look something like this. But if you want to actually sketch this graph, you have to look at the various traces. So for example, let's look at some of the z traces for this graph. So what we're going to do is we're going to take this equation right here, and we're going to let z equal some z naught value, and we'll take different values for z naughts. Usually, the most efficient choice for z naught is to pick z naught equals 0, but sometimes you need to pick additional z naught values to get a good idea of what this particular quadric section is going to be looking like. So let's go ahead and let's just let z equal 0 in this equation here. So if we do that, we would have x squared over 4 plus y squared over 9 is equal to 1. So when we restrict ourselves to the plane where z equals 0, which means we're in the xy plane, what type of shape is this? And this is where we needed our review of conic sections, because this is an ellipse and then since z is equal to 0, this is in the xy plane. And you can see, the author's already gone ahead and given the solution to this. And here is that slice. This is that slice right here where z is equal to 0. And we can see in the plane there, in that particular plane, the trace of this graph looks like an ellipse. Okay? We could also do this for z is equal to 2 or z is equal to -2. And if you were to do that, you would have, let's let z equal 2, for example. Let z equal 2. So you'd have x squared over 4 plus y squared over 9 minus 2 is equal to 1. And if we add that over, we get 3. But we recognize this is, again, another ellipse, which is why we end up, oops, and folks, I had a mistake here. That should be quantity squared. Good, I was a little worried about that. That should be plus 4 equals 1, or we get x squared over 4 plus y squared over 9 is equal to 5. And this is, again, ellipse, and even if I picked another sign value for z, this would always result in some sort of ellipse. So all of the traces in all of these planes where we're looking at something that's parallel to the original xy plane there, we're always going to have an ellipse for that trace. Okay. So let's continue on, and let's look at the xz trace. So to look at the xz trace, what we'll do, so when I say xz trace, I mean we're in the xz plane. So in the xz plane, anywhere inside this plane, what are the y coordinates in that plane? They're 0. So we'll let y equal 0, and when we do so, we end up with x squared over 4, and then we would have the plus y squared over 9, but we're letting y be 0, so we get minus z squared is equal to 1. Now, this requires us to remember what type of conic section this was. But this is a hyperboloid, and it's going to have x-intercepts but not z-intercepts based on the work that we did in that previous example. And so we would expect that its trace, if we were to sketch the xz plane here, so let's see here, let me put a coordinates on here, here's x and z, we would expect its trace to be some sort of hyperboloid, and that's precisely what we see in this nice diagram here. And in fact, if we shifted this over to other planes, we would still have traces that were hyperbolous. Folks, I made a mistake here. I said hyperboloid. This should be just a hyperbola. Hyperbola is something in a plane. A hyperboloid might be something that's in 3 space. Okay? And I'm not going to work through this. I'll let you do this. Check and confirm that if you were to look at the YZ trace, so the YZ trace, we would let Z be 0, or excuse me, we'd let X be 0, confirm that we again get a hyperboloid. And then from those traces, if you put all 3 of those traces together like the author did here in this skeleton sketch, you see how we get a sketch of the hyperboloid. Okay, so we're going to do a lot more of this trace analysis when we get to class. But what I've done here is I've gone ahead and given you a table from the book where we've got the sketches of a number of the quadric surfaces. Now, these are all the quadric surfaces, although, for instance, here I've got a elliptic paraboloid where it's the parabola shape is along the paraboloid is parallel to the z-axis. We could have other paraboloids, so I'm not showing you every single type of quadric surface that you could encounter, but up to the variables, that's what we're seeing here. And I actually just want you to spend some time studying this table. Okay, so just take some time thinking about the traces like we talked about. And that's all I want you to do on this page is just kind of examine this table. And then I'm asking you to put that into practice on the next page here. So what I'd like you to do is, based on that table, identify what types of shapes that we're looking at in each one of these examples. So go ahead and say, okay, let's see here. We've got y to the first power, and we've got z squared, x squared. We've got some sign differences. Let's go up here and look at this table and see if we could figure out what that might be. Okay. And let's see here, I think that we would have something like this, this final one, this hyperbolic paraboloid of some sort. And so that would be our solution to this. So please, what I want you to do is take some time, study this table, and then try to identify what type of quadric surface we're looking at for each one of these. Okay. Folks, eventually you will need to have these quadric surfaces memorized. That is, eventually I want you to be able to look at this and state which of these types of quadric surfaces we would have just by looking at the equation, as long as the equation isn't too messy. There's not too much initial work you have to do to reorganize it. Okay? So these are the possible answers to these questions, and I'll let you go ahead and take a shot at those. It is possible to, if you want to see the answers, if you click right here on that, I think on the colon or right around there, there should be a hyperlink. If you click that, it will actually take you to the solutions to this. So I've got one more thing I want to make sure you do in this pre-work, and that is going forward, we're going to actually be wanting to look at a lot of 3D graphs, and we're limited in our ability to sketch something. So I'm asking all of you, if possible, to go ahead and download the Wolfram CDF player. By the way, you'll need to download this anyway to do some of my math lab exercises that have Wolfram Mathematica code in them. So it may be worthwhile just doing it now. Anyway, you can download it by clicking this link here. It's a large-sized file. It's about 980 megabytes. So if you can't do it, I completely understand, but I would encourage you to do so, because looking at 3D graphics is exceptionally important here in Calc 3. The next thing is if you want to go ahead and test it out to make sure everything's working, you can click to download this Mathematica file here, and you can open it and start looking at your quadric surfaces. Okay. Folks, that's all I've got for you. There's a fun little note there, but only if you have time. Anyway, I hope this was a quick, useful overview of these quadric surfaces. We're going to be studying these ideas of traces like we did in this example here when we get to class. Great. Thank you so much for your patience, folks, and I will see you in class next time.